kubectl get all command is a lie. It does not get all. It gets maybe 10% of what's actually in your cluster. And if you want the other 90%, well, you're going to write bash loops. You're going to wait forever. And you're still going to miss resources because you don't even know what to search for. This video is about fixing Kubernetes' terrible query story. The root cause is etcd. It's a key value store, not a database. It was never designed to answer questions like, hey, show me all databases, or what is running in this namespace? I will show you how to sync Kubernetes metadata into a vector database, and that will enable both traditional queries and semantic search. By the end, you will be able to run proper database queries and ask questions in plain English, and to get answers that actually make sense. So no more grep pipelines, no more guessing resource names. So let's start by listing all the resources in the cluster. Simple request, right? The output shows over 100 resources. But here's the thing. Those are not all the resources. kubectl get all retrieves only core resources. And not even all of those. Ingresses are not there. Custom resources are not there either. Most of what makes up your cluster is missing from that output. That's the stupid part of Kubernetes. If we want all resources, we need to find out what all even means. There are, in this cluster, 356 resource definitions. There can be resources based on any of those. So those 100 or so resources we saw earlier could be all the resources in the cluster, or they might be a few more, or a few thousand more. Who knows? Now, to actually see everything, we need to iterate over all APIs and execute kubectl get for each and every single one of them. I'm going to filter out events, exclude those since they're constantly changing and they're noise that would just clutter the results. So let's see how to get all resources for real. So look at it struggling. It's working and working and working. And eventually we get something like this. That over there was a stupidly silly way to get something that should be table stakes. That's madness. And this isn't even a real production cluster. So let's spice it up a bit more. How many resources are there in the .ai namespace for each kind sorted in descending order? Now we are waiting for it to list all resources for each of the 356 definitions, and that's an exercise in patience. Eventually, if I fast forward, we get the data, and it tells us that there are over 1,500 resources in the cluster. Now that is a very different picture from the 100 or so we got with kubectl get all. Now, if that was SQL or any other database, it would be faster and more intuitive, right? So let's spice it up a bit more and let's see whether we can find all the databases in the cluster. Simple request, correct? Now, what makes us think that all databases are stateful sets? Let's try another resource type. So, did we now get all the databases? Well, who knows? As we saw earlier, there are 356 resource definitions in this cluster. There could be any number of other resources related to databases. So, can we figure out which definitions are related to databases? Now, what if names of database-related resources have DB in the name instead of database? So, are those all? We don't know. Names can have SQL or PostgreSQL or Postgre or pSQL or any number of other synonyms for a database. So, did those examples find all the information we were looking for? Well, not even close. Were those easy? No. Were they intuitive? No, absolutely not. Will everyone be able to write such commands and scripts depending on what they're looking for? Well, most likely not. Heck, how can we find something if we don't even know what we're looking for? Now, imagine more complex queries. It would be a nightmare, and it would be a nightmare mainly caused by Kubernetes' decision to use etcd. It is a key value store that might be a good choice for its primary function of managing state. But it's a terrible, terrible choice when it comes to querying. Horrible. So, what do we need? We need data that can be searched both through queries and semantic search. And that's where vector databases enter into the picture. Let me show you the same query against a vector database that automatically gets populated with all resource definitions and metadata from all the resources in the cluster. It's all there. Now, the first thing you will notice is that that command, or the execution of that command, was almost instant. We got all the resources in the database without any delay. And since it is a proper database, we can write any query we like to filter and slice the data. Now, do I expect you to write CURL commands? No. I expect you to use a web UI or a CLI or an AI agent or any other interface you prefer. And in this case, I will use Cloud Code with an MCP server that connects to the vector database. So let's ask it to show, let's say, all the resources in the cluster. Now, that over there took a bit longer, but that's because we are not just fetching data. The semantic search against the vector database is close to instant, but AI then goes through the results, checks them, adds additional information, formats the output, and so on and so forth. It's a different way to massage data than raw output from the database. Still, AI had to start with a complete list, and that was so much easier to fetch from the vector database than from Kube API. Now, let's ask it to show how many resources there are in the .ai namespace for each kind separately. Look at that. It found resources that the Kube API would not find without going through each of the 356 definitions one at a time. And it did that relatively fast. Now, let's ask it to find, let's say, all databases. Now we're talking. It found database-related resources no matter whether they're called DB or database or PostgreSQL or anything else. That's the power of semantic search. It understands meaning, not just exact text matches. If it's related to databases, it found it. One is based on a stateful set, another is based on CloudNativePG. There is the Qdrant vector DB where the actual data is stored, and there's an AWS RDS instance made with Crossplane. Now, as icing on the cake, that data is accessible from anywhere. So we can, for example, show it in a web UI. Now, that page is dynamically generated based on a combined response from the database where resources are stored and AI analyzing the data. At the top, we can see AI-generated insights about what was found, including observations about the multi-database architecture and any issues detected. Below, there are visualizations generated by AI. Those could be diagrams, tables, code, graphs, or whatever else AI decides is the best way to present the data. The UI just renders what AI tells it to. Now, I have much more coming up related to the web UI. This is just a taste. The only thing I will say for now is that it is fully dynamic. None of those tabs are predefined. Stay tuned. More is coming. So, long story short, etcd in Kubernetes is a good system of record, but it's not a real, whatever real means, it's not a real database. It's a key value store. If we put data into a database, we get queries. If that database is a vector database, we get semantic search. If we combine queries and semantic search, we can find anything. And if we can find anything, so can AI. Nevertheless, we need to be careful what we sync into the database. Everything? Bad idea. Kubernetes is very, very noisy with logs, events, constant status changes, and so on and so forth. What we likely need to sync into a database is metadata. That changes less frequently, so we can sync it reliably and fast. So, what's the bottom line? Ask anything and you will be answered. I dare you to come up with a question it will not answer, as long as it can be answered based on Kubernetes metadata. If you do, please let me know and I'll try to fix it, improve it, I'll do something. Now, you can build this yourself. That's the main purpose of this video, or you can use the solution I built. Check out DevOps AI Toolkit, and while you're at it, give it a star, please, or fork it if you like to contribute, or open any issues or feature requests you think would improve the project. So, here's how it works. You can use this pattern that I will explain to create your own solution if that's what you prefer. It starts with controllers that watch the Kubernetes API and sync CRDs and resource metadata into a vector database. In this case, it's Qdrant. The vector database enables both traditional querying and semantic search. From there on, when a user asks a question, the request goes to an MCP server. That server actually exposes both MCP and REST HTTP protocols. That means that generic agents like Cloud Code or Cursor can use it. So can any other client like a web UI. The server handles the heavy lifting so your context does not get polluted with raw data. From there on, server calls an AI agent that knows what to do with the data. The agent enters a tool loop, and it can perform semantic searches, query resources, or even call kubectl for live data like logs and events that change too frequently to sync. And once it is satisfied, it returns a summary along with data needed to generate visualizations. That's it for today. Thank you for watching. See you in the next one. Cheers.